Okay, today we're going to get into our last lesson of Unit 8. Our learning target for today, it says, I can solve a linear quadratic system by graphing. So if you remember in our work with systems of equations, that always means that we have two equations. So in this lesson, we're going to be working with two equations at the same time, one of which will be linear and one of which will be quadratic. For our do now today, we're going to take a look at number 5 in your Regents packet. So go pull up your Regents packet and a piece of paper to try this problem. So the question says, which point is not in the solution set of the equation 3y plus 2 equals x squared minus 5x plus 17? So we want to know which is not part of this solution. Now there's a few different ways that we could solve this. We could go ahead and just substitute all of these x values in to see which y works. Another thing that we could do, since we like to use our graphing calculator to help us, is rearrange this equation into a form that could be graphed, and then our calculator would essentially just do this work for us. I know that in order to graph this in my calculator, it needs to be in the form y equals. So in order to get this y by itself, first I would have to move 2 to the other side by subtracting 2. Notice that I'm allowed to subtract 2 from 17 because those are like terms. Finally, I could divide by 3. Now what I need to do here is divide each term here by 3. So if we divide all these numbers by 3, we're actually going to get some pretty messy numbers. So I'm just going to leave this as 1/3 x squared minus 5/3 x, but then I can simplify 15 divided by 3 because I know that's 5. So let's go ahead and graph this function here. Notice I already have this typed into my calculator here, and I want to know which point here is not in the solution set. So if I look, the last choice is 5, 5. If you notice right here, I see that that is a point. If I look here at the point 2, 3, I see right there that 2, 3 is a point on my graph. If I look at -1, 7, I see that -1, 7 is also a point. So it looks like our first answer choice rather is going to be the case, because at -2 I get 9.667, which is not exactly equal to 10. So looking back at our answer choices, we see that choice 1, this point, is not part of our solution. It is not on the graph. So again, our lesson today is all about systems of linear and quadratic equations. We're going to take a look at this first word problem. This is in the packet Real World Quadratics and Quadratic Linear Systems, and we're going to be starting on page 5. So the question says, John and Sarah are each saving money for a car. The total amount of money John will save is given by this function here. So this represents John. The total amount of money that Sarah will save is given by this function here. So this is for Sarah. Then our question wants to know here, after how many weeks x, so we're trying to solve for x, will they have the same amount of money saved? So I want to know when they'll have the same amount of money saved. So if we think about that, the question is basically asking us, when is John equal to Sarah? So the expression that they gave us for John is 60 plus 5x, and the expression that they gave us for Sarah is x squared plus 46. So we're asked first to solve this problem algebraically. Again, algebraically means by showing our work. So looking at this equation here, I notice I have a linear and a quadratic. We learned when we learned how to solve quadratic equations to put our equation in standard form, meaning to move everything to one side of the equation and just be left with a 0. So I'm going to move everything over here to the right side. So I'm going to subtract 5x from both sides. And also at the same time, let's go ahead and move the 60. So we're left with 0 equals, bring down the x squared, bring down the minus 5x, because there are no like terms to go with those, but we can combine 46 minus 60 to be minus 14. Now again, we learned 4 different ways to solve this equation. We have square roots, factoring, completing the square, and the quadratic formula. I know that I can't use the square root method because I see two x variables. So the next method I like to try is factoring. So let's see if we can go and factor this expression. I'm going to set up both of my parentheses starting with an x. And we want to know here what two numbers multiply to give us c, which is negative 14, and add to give us b, which is negative 5. So the two numbers that we should be using here are negative 7 and positive 2, because negative 7 times 2 is negative 14, and negative 7 plus 2 is negative 5. So lucky for us, this expression can be factored. Let's go and fill in those two numbers that we got. And we know that at this point, we should then use our zero product property to solve for x. So we'll set both expressions here equal to 0, and we'll use our inverse operations to solve. So our first answer will be 7. Our second answer will be negative 2. Now, if we think about in this problem, it was asking us after how many weeks. So one of these answers doesn't make sense, and that answer would be negative 2. There's no such thing as negative 2 weeks. So the answer that we're going to focus on here is the 7, and that means that after 7 weeks, they would have the same amount of money saved. Because if we substitute in 7 for x, we get the same answer. Now, the rest of this problem here wants us to confirm our answer by solving graphically. So let's go ahead and graph both of these equations. Again, you can use your calculator here. If you come back to y equals, you can type into your first equation here, y equals 60 plus 5x. And let's go ahead and graph our other equation at the same time, which is y equals x squared plus 46. So let's go ahead and zoom out and take a look at our graph. So we see our graph right here. Again, our blue graph was our linear function, and our green graph was our quadratic function. So if we zoom in here, we see that they do intersect right here at 7,95. So let's go ahead and graph the solution. Again, you can just kind of click around to choose different points to graph. So let's take a moment to graph on our paper. I'm going to go ahead and count by tens on my y-axis so I can fit this. And let's go ahead and plot our points. Again, you can be clicking back and forth between your graph to plot. So my first line here, this is going to represent John, so we can label this as John. He was our linear function. And then let's go ahead and plot Sarah. And you can feel free to plot as many points as you'd like. The more you plot, the better. But again, we know here by looking back at the graph that we had that they crossed at 7,95, which tells us that after 7 weeks, they both have $95 saved. So you can see here that we're now combining all the knowledge we've learned about linear and quadratic functions to solve problems that involve both of them at the same time. Let's go ahead and take a look at our guided practice. We're going to jump back into our Regents packet for this question. Please go over to number 19, and we're looking at the following problem. We want to know, when do these two graphs intersect? Now, I'm actually going to use the calculator that we usually would use in school to show you a feature of this that we would have been doing in school. So So if you take a look, here are our two equations. We have x squared minus 3 and 3x plus 4. If we go ahead and look at the graph, we notice that these cross once, twice. So we notice that we can actually focus on answer choices 3 or 4 because those have two different answers. Now to see where these cross, we could come and look at our table of values by hitting second table, but I noticed by looking at my answer choices that they're all decimals. So here's another way to get our answer. If you go to second trace in the calculator and you go down to intersect, it's going to ask you 3 questions. You can basically just hit enter, 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 and you'll notice here that they give us our first answer, which is 0.38, comma, negative 0.285. So I see that answer both in choice 3 or choice 4. So now we need to go and figure out, well, what is this other point of intersection here? So again, we go back to second trace, we come back to intersect, but now we're going to move our cursor to the right. I'm hitting right to get a little bit closer to this point of intersection. We hit enter, 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 and you'll notice here's our second point of intersection. It's about 2.62 if we round, comma 3.85. So if we come back to our packet right here, we see that this is choice 3. Again, we knew right away that they crossed twice, so we could eliminate choice 1 and 2, and using that function in our calculator, we got choice 3. So let's go ahead and try our checkpoint. This one will be a little bit easier than the guided practice. Please right now go ahead and pause this video and then come back to check your work. Okay, so looking at this checkpoint question here, I notice that I have to graph 2 equations. So hopefully you use your graphing calculator to help you with this. So our first equation is x plus 5. Our second is x squared plus 5. So coming down here, if we zoom in a bit, so you'll notice the calculator was actually highlighting the 2 answers for us here. We see first that these two intersect at 0, 5, and then they intersect again at 1, 6. So there are 2 answers for this problem, 0, 5 and 1, 6, which we see that represented as choice number 1. So you should have chose choice number 1 for your checkpoint. Please try to sketch a little graph so that we can see what your graph looked like before you get into your practice. So for our practice today, if you chose choices 3 or 4 for your checkpoint, or you really had no idea how to solve this, please start with red. If you chose choice 2, please try the yellow questions. And if you got this correct and chose choice 1 and you knew how to get to that answer, please try your green. Everyone should also notice that you also know how to do 2 more problems in your Regents packet at this point. So right now, please pause this video, go take about 15 minutes to try this practice, and then come back to check your work. Again, these practice problems are coming from your regular packet, the packet that says Real World Quadratics and Quadratic Linear Systems. Okay, at this point, you should only be listening if you've already gone and tried your independent practice by yourself. Let's see how you did. Here's number 1 on page 5. Here is number 2 on page 6. Here is number 3 on page 6. Here is numbers 4 through 7 on page 7. And here are numbers 8 and 9 on page 7. Again, if you have any questions on this lesson, feel free to contact any of us or come to Extra Help. You can also watch the Khan Academy video posted that might help you to better understand how to solve problems involving linear and quadratic systems. Your last task of this lesson should go and be to try to do number 2 on the exit ticket. At this point, you've also should have done now both questions on the exit ticket, so you can go ahead and submit that at this time.